Okay, so we've done measuring length, we've done measuring area and volume, and now we're going to talk about weight and temperature. So units of weight in the English system, there aren't that many. 16 ounces is equal to 1 pound. Okay, think about, weighing a baby. We talk about how many ounces they are when they're born, or if you're baking. Okay, you're looking for a pound of shredded coconut. Okay, it's going to be 16 ounces on the package as well. And then 2,000 pounds is equal to 1 ton. Notice that ton is with a capital T. That's very important. And notice that ounces is OZ, okay, because the last letter sort of sounds like a Z, so it makes it a little easier to write there. And then pound is LB. We thank the English for these abbreviations. In the metric system, our basic unit of weight is the gram. And again, we're using a metric line. King Henry died drinking chocolate milk is still the same, but in the middle, we're going to have a G for gram. And so when you're converting from one metric unit to another, you're still only moving the decimal, the number of places that you have to move on the metric line. Okay, so some of the metric units that we use today, even though we're not a metric country, we still use some metrics in certain things. Can anybody raise their hand and tell me one place where they might see either the conversion of capacity or of weight that we've talked about today? Okay, engine sizes. Now, a lot of people wouldn't know that, okay, because I know I don't measure my engine. I'm not a mechanic. I don't do that. But, yeah, very much so they use the metric system. If you are a mechanic, you're going to need to be proficient with the metric system. Anywhere else in your everyday life? Yes, sir. Medicine. Okay, what do you see on medicine? 500 milligrams or whatever it might be. So milligrams on, your ibuprofen or your Tylenol, you're going to see milligrams on there. And then the one of capacity, the one we just did in 9.2 of capacity, what was the main unit of capacity in the metric system? Liters. Soda. Okay, so you see 2-liter bottles of soda and so on. So again, even though the U.S. mainly uses the English system, you're still going to see metric units in your everyday life. Okay, this is still very applicable. So being that medicine is using the metric system, if you're going into the medical field, then the metric system is going to be very important to you. So just again to review some of the conversions that we did last time in the metric system. If we want to convert 4.2 decigrams to milligrams. So again, just to remind you of what that metric line looks like. So grams goes in the middle. And so King Henry died, but this is the DA, drinking chocolate milk. And then you just add the little G behind it. So there's your metric line. And so from decigrams, that's the little d, you need to move to the right 2 spaces to get to milligrams. And so in this number, we're going to move the decimal 2 places to the right. Okay, so moving it over 2 places to the right, there's your new decimal. Don't forget that when you have a blank space, you need to fill in a 0. So you get 420 milligrams. Okay, so now comparing English to metric. So 1 ounce is equal to 28 grams. 1 pound is equal to 0.45 kilograms. 1 ton, notice capital T, is equal to 0.9 tons, lowercase t. So notice that on the left we have the English ton, on the right we have the metric ton. And notice the difference in spelling. So capital T means it's an English ton, lowercase t means it's a metric ton. So If you are in law enforcement, anybody think about where these measurements come into play? Drug bust, yeah. Okay, so, you know, in law enforcement, I'm hoping that's the only place you'll be familiar with the drugs, is in law enforcement or on the movies. Okay, and so, you know, you've got grams and kilograms and so on in those measurements. Okay, let's bring it back to maybe the medical field, okay? So if you have a person that weighs 160 pounds, most medications are based on a person in kilograms. And so if you're in the medical field, you have to be able to convert your pounds to kilograms. Now, in some books use a different conversion. They'll use 2.2 pounds per 1 kilogram. But this is the same thing. We're just basing it on 1 pound. Okay, so 1 pound is equal to 0.45 kilograms. And so again, using dimensional analysis, start out with 160 pounds over 1. And then form your unit fraction. This process has not changed, only the units that you're using are. So you want to write your pounds diagonally across to the denominator, kilograms up top. So putting 0.45 kilograms over 1 pound, multiplying across, you should have gotten 72 kilograms. Okay, so ladies, if you're wanting to feel lighter, just change your weight to kilograms, and your weight goes down a bit. Go ahead and convert 300 grams to ounces using dimensional analysis. So again, you should have started with 300 grams over 1, and then created your unit fraction based on what you know of grams and ounces. And so hopefully you set up your problem like this. So 300 grams over 1 times 1 ounce over 28 grams, which means you have to divide the 300 divided by 28, giving you approximately 10.71 ounces. So any questions on converting your measurements of weight? Okay, so I mentioned that chart was going to come up again in 9.3, so here's where it is. If you have 1 cubic centimeter, we already discussed that you could fill that cube with 1 milliliter. But if it was water in there and you weigh it, it will be equal to 1 gram. Okay, so again, the nice thing about how the metric system works, it's very even to each other. Now notice that we're specific about water. 1 cubic decimeter is the same as capacity of 1 liter, and that's going to weigh 1 kilogram. If it was molasses, would it necessarily weigh the same? It'd be close, but not maybe exactly equal to 1, okay, because of density. So this is why they based it on water, and they say specifically water. 1 cubic meter it can hold a capacity of 1 kiloliter, and that is going to weigh 1,000 kilograms, which is 1 metric ton. An aquarium holds 0.145 cubic meters of water. How much does that water weigh? Okay, so notice that we're going from volume to weight. So you need a comparison of cubic meters. Okay, but where did you get that from? What comparison did you use?
Because 1 cubic meter is the same as
Yeah, we want to go with 1 kilogram. The metric ton is going to be too big here. Okay, it's something that you can't necessarily visualize and so on. So we want to use the kilograms here. So putting your 0.145 cubic meters over 1, and so your unit fraction should be 1,000 kilograms over 1 cubic meter. And then when you multiply, you get 145 kilograms. Okay, so this could be important. You order an aquarium, it comes in cubic meters. You have to know how much the water weighs because you need to make sure that you put it on something that can hold that weight. All right, if you don't think about how much water weighs, it weighs a lot. You need to make sure it's got a sturdy counter or stand to hold it. So let's say you're looking for a stand, you don't find one you like online, you have to go to the store locally. It's possible that the stand will not tell you how many kilograms it holds because you're in the US. It might tell you how many pounds it can hold. So in this case, go ahead and convert this now to pounds. So what's 145 kilograms in pounds? Okay, 1 pound equals 0.45 kilograms. So start out with your 145 kilograms over 1. Set up your unit fraction. Remember, kilograms has to go diagonally to the denominator. And so hopefully this is how you set up your problem. 1 pound over 0.45 kilograms, so when you divide, you get approximately 322 pounds. So should you get a stand that holds exactly 322 pounds? No, maybe 350, something over, you know, because it's not just going to be water in there, there's going to be rocks, there's going to be, okay, you got to account for that stuff. And plus, you don't want to make it right at the limit, okay? If there's any margin for error, that stand is breaking. All right, and then the last thing we're going to talk about is temperature. We're not going to talk about all of the temperature measurements that are in the textbook, but we're going to talk about the two main ones. Celsius to Fahrenheit and vice versa. Now on your handout, this is the heading that's on the left. So this formula is the one that goes under your left heading, which is F equals 9/5 C plus 32. So if you have the Celsius temperature and you want to convert it to Fahrenheit, then this would be the easiest formula to use. Now if you're given the Fahrenheit temperature and you want to convert it back to Celsius, well, that's the same as getting C by itself, okay? If you took intermediate algebra, you practiced doing that, right? Solving a formula for a certain letter. We got to subtract 32 to both sides and then multiply both sides by the reciprocal. So that's where this other formula comes from. So this is the heading on the right-hand side of your handout. From Fahrenheit to Celsius, C equals 5/9 times the quantity, it's in parentheses, F minus 32. The parentheses are very important. Don't forget that you have order of operations. If you're substituting a number in for F, you have to do what's inside parentheses first and then multiply by the fraction. So taking a look at some problems that would use these formulas. Your European vacation has you feeling a bit feverish. By the way, if you grew up in another country, don't give away the answer, okay? Give people time to work it out. Okay, your European vacation has you feeling a bit feverish, so you decide to take your temperature. The thermometer reads 37 degrees. Should you panic? Well, if you're in Europe, hopefully you know that they use which scale for temperature? Celsius. Okay, so they handed you a thermometer that reads Celsius. But if you grew up in the U.S., you only know your temperatures, you grew up knowing them with Fahrenheit. So you need to convert. So Celsius to Fahrenheit. So that's our formula of F equals 9/5 C plus 32. Okay, so substituting in your 37 for C. Okay, you have an option. You can multiply 9 times 37 and then divide by 5. Or if this was a number divisible by 5, you might want to divide by 5 first. Okay, but it's not. So you can do 37 times 9 divided by 5. And then the last thing you're going to do is add 32 to your product there. So again, order of operations is very important in these problems. So when you multiply 37 times 9/5, you get a decimal. I believe you get a repeating decimal. All right, so 66.6. And then plus 32, you get 98.6. Okay, so 66.6 plus 32 Gives you 98.6 degrees Fahrenheit. No need to panic. Good. Okay, no need to panic. This is perfectly normal. Okay, 98.7 is normal. 98.6, 98.7. Okay, the temperature on a warm spring day is 77 degrees Fahrenheit. Find the equivalent temperature on a Celsius scale. So this means that you're using your other formula. Okay, so substituting in your 77, what do you have to do first? 77 minus 32. Do the subtraction first, and then multiply by your fraction. Okay, so substituting in 77 minus 32 is 45, and when you multiply by the fraction, you get 25 degrees Celsius. So any questions on a problem like this? And then normally we write the little circle up there, the degree symbol, and the abbreviation for the temperature, the unit of temperature there for Celsius. All right, let's take a look at some more problems from the homework. Okay, so a quiz is going to be coming up now that we've finished all of Chapter 9. So notice that some of your conversions are strictly metric to metric. And so remembering your metric line, okay, G being in the middle, 3 to the right, 3 to the left. This is how I like to make my metric line. And then King Henry died with a DA, drinking chocolate milk. Okay, so milligrams to grams. So we're starting at milligrams. So where do I have to go? 3 to the left. So currently, I don't see a decimal in my problem, so where do I put it? Okay, behind the 0, and I have to go 3 places to the left. And so that leaves me with 0.780. Do we really need the 0 at the end anymore? No, we can drop that 0. So 0.78. So any questions on the metric system? Okay, 0.78. Good job. We're converting 4.5 kilograms to cubic centimeters. So where do we have a comparison between kilograms and cubic centimeters? There's a couple ways you could do this. There is a direct comparison. 1,000 cubic centimeters right here is equal to 1 kilogram. Okay, so there's going to be lots of different ways you can do this, especially with the metric system. You could have gone from cubic centimeters to grams and then convert grams to kilograms, but there is a direct comparison, so we might as well use that direct comparison. So starting out with 4.5 kilograms over 1, that means that kilograms has to go on the bottom, cubic centimeters up top. So that gives us 1,000 over 1. Okay, so multiplying by 1,000, that's the same as moving our decimal 3 zeros, 3 places to the right. And so we get 4,500 cubic centimeters. So again, if you happen to, some of you guys looked at it a little differently, and that's okay. If you take it a different route, you know, if you choose to go to grams first and then convert grams to kilograms, or sorry, the other way around, convert kilograms to grams first and then go back to cubic centimeters, you can do that. It's up to you. But the direct comparison is going to be the fastest. Okay, so 4,500, excellent. Okay, so they want you to do ounces to grams. Notice this chart has all of the weight comparisons here. And so if we're converting 25 ounces to grams, then we need to know that 1 ounce equals 28 grams. And again, start with what you have over 1. Ounces has to go on the bottom, grams up top. And so that gives us 28 over 1, meaning that we have to multiply. The more you practice the dimensional analysis, the easier it's going to get. Okay, that you're just going to think, okay, that over 1, now set up my fraction. So what is 25 times 28? 1,100? 700? Okay. All right, so 700 grams. Excellent. Okay, for each kilogram of a person's weight, 2.5 milligrams of a drug is to be given. What dosage should be given to a child who weighs 71 pounds? And they give you the hint. Use the fact that 1 pound is approximately 0.45 kilograms. Okay, so they've talked about a few things in here. We're going to reread the problem, those strategies for problem solving. So for each kilogram of a person's weight, 2.5 milligrams needs to be given. We know that this child is 71 pounds, so the first thing we have to do is pounds into kilograms, right. So we have to know the person's weight by kilograms first. So starting out, 71 pounds over 1. And then we can use the fact that 1 pound is approximately 0.45 kilograms. Okay, so pounds has to go diagonal, kilograms up here, and we have 0.45 over 1. So 71 times 0.45, what do we get? 31.95. Okay, so, but this is the final answer. Okay, so be careful on your rounding. It's set, okay, so we get 31.95 evenly? Okay. It says round to the nearest whole number as needed, but that's the milligrams that you're rounding to. Okay? So here's the weight of the child, and we know that for each kilogram, let me show you how you can create a new conversion now. For each kilogram, so 1 kilogram, you need to give 2.5 milligrams. So this should be equal to 2.5 milligrams of the drug. So notice I created my own little conversion. It's not a part of our charts. It's what's given in the information. So now, start with the weight, 31.95 kilograms over 1. And as far as converting it to how much of the drug, I'm going to use these units now. Kilogram goes in the bottom, milligrams up top, and so 2.5 over 1. So now take your weight and multiply it times 2.5. 79.875. Okay, right, so it tells us here round to the nearest whole number. So that would round to 80. So approximately 80 milligrams is what you need to give that child. Now let's see if I was right about not rounding too early, because sometimes these problems say, no, don't round at the beginning, then round at the end, or sometimes they say round the whole time. Okay, so 80 milligrams. Everybody have that was writing it down before it disappears? Good job. All right, so you're going to have a couple application problems like that where you need to do your conversions a little differently. So your homework then is 9.2 and 9.3.